Now, up till now, we've been talking B cell activation in the presence, the requiring of a T cell. Well, Mother Nature can be a little bit more obtuse than that. Mother Nature likes a little bit more going on. So, what we have evolved over the past few 100 million years, up till now we've been looking at the T cells, we've been looking at thymus dependent. Have to have a T cell, thymus, T cell. Thymus dependent B cell activation. Keep in mind, at the beginning of this chapter, we discussed that there was also a thymus independent method for B cell activation. Well, turns out certain bacterial antigens do not require T cells to activate B cells to go through proliferation as well as, becoming a plasma cell. What we find is if you get a high enough concentration of certain antigens, certain bacterial antigens, LPS, things like that, certain endotoxins, these will bind to certain receptors on the B cells, which will trigger clonal expansion, rounds and rounds of mitosis. You get low levels of this, well, only certain B cells will then be triggered. Only certain B cells will then go through clonal expansion. It is all dependent upon concentration. High enough concentration, everybody gets bound. There's enough stuff there to trigger everything. Now, a lot of times we find that this could be a bit indiscriminate. Certain endotoxins like LPS are indiscriminate upon which receptors they will glom onto, and yes, I use the term glom onto literally because they're not a ligand. They don't bind, as you've learned in your cell biology courses, ligand receptors. They're not the correct ligand, but they glom on enough that they can trigger the cell irregardless. So you end up with polyclonal B cell activation across quite a few clones, and you get a lot of antibody produced. Lower levels, lower concentrations, it's going to be a select few that show a greater affinity. So these bacterial polysaccharides, they're highly repetitive in structure. Because of this highly repetitive structure, they're able to glom onto a wide range of receptors, not only B cell receptors, but pretty much quite a few receptors you're going to find on all cells. They have no intrinsic B cell stimulating activity. We don't know why. We're learning why, but for some reason the B cells get triggered the hardest. Activates only mature B cells. So naive B cells that haven't gone through maturation, polyclonal expansion, and all this yet, well, they are a little more, they can withstand a higher concentration of these polysaccharides than resting or mature B cells can. What we're finding out is something about the repetitive structure of these polysaccharides cross-links quite a few of the B cell receptors. By cross-linking, it triggers intracellular signal cascades reminiscent of a T cell receptor that is linked to a B cell receptor. And those signals that we see from that are quite similar to the ones that the LPS can trigger. So when you look at it, long endotoxin, lots of repetitive, you get the stabilization of numerous B cell receptors. Like I said, quite similar, to what you would see with the T cell. It's a stable interaction that this mimicking will trigger the B cell to go through and begin producing IgM. Now, if this endotoxin, this LPS, this polysaccharide, is presented via a follicular dendritic cell, the follicular dendritic cell going to stabilize, hold. Again, normal B cell receptors, as we just saw, are all going to be stabilized. It's going to trigger a response similar to what a T cell would, but a second signal, here they're showing BAFF, a second signal from the follicular dendritic cell, a cytokine, will induce class switching. So start off production of IgM, and as it goes through the maturation process, we'll begin seeing the class switch that was discussed in the last lecture. So whether you're talking a T1 or a thymus dependent or a T1, T2, thymus independent. Remember, this is going to have to be about what the source of that endotoxin or that polysaccharide is coming from. It will induce different responses from B cells, whether it's an infant or a mature organism with matured immune cells.